Welcome to qnawire.
Hello, so today we're just going to draw a couple compounds. Let me zoom in a little bit. So, the first one that we have to draw is phenyl benzoate. So, first things first, let's just make a phenyl group. So, a phenyl group is just a benzene ring that's attached to an oxygen. So, and then the second part is the benzoate. So benzoic acid is just a carboxylic acid with a benzene as its alkyl base chain. So let's recreate that. So there's our carboxylic acid formed into our ester. And then let's just add this. So as you can see, here is the benzoic acid. And then once we attach another benzene to the oxygen, it becomes phenyl benzoate. Okay, on to N-ethyl, N-methyl butanamide. So N just means attached to the nitrogen. So that means we have an ethyl group and a methyl group attached to a nitrogen. So let's start with that. So so there's our methyl and there's our ethyl attached to our nitrogen. And we know the nitrogen is part of the carboxylic acid derivative, so let's make that. Oh, okay. And what is attached? What is our base alkyl chain? It's, as you can see from the butan prefix right here, butan, that means we have a 4-carbon base chain. So 1 is already bound to the oxygen, so that's 1. Here's our second, our third, and oopsie, our fourth. So it looks something like that. So we have our 4 carbons on our base chain, and then we have our methyl and our ethyl. Cool. So let's move on to 2,4-dimethyl pentanoyl chloride. So pentanoyl chloride is the big key. So first thing we want to do, let's make our pentanoyl chloride, which just means we have this OCl and its base chain is a pentane. So we have 1 carbon here, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And then we have a dimethyl, 1 on the 2 and 1 on the 4. So this is the first. We'll go to the second, and there's our methyl, third and fourth. So there we have it, 2,4-dimethyl pentanoyl chloride. Okay, on to the next one. So we have methyl, 1-methyl cyclohexane hexane carboxylate. So when we have this weird looking methyl out in the front, that means we're likely dealing with an ester or a thioester. And we can see that for carboxylate. So first thing we want to do is make our ester. So 1, 2. All right, there is our methyl ester. And what do we have attached to it? We have a 1-methyl cyclohexane carboxylate. So this right here we know is the carboxylate. So that means we have to go one back, add our methyl, and then add a cyclohexane. Something like that. So that's all this is. It's we have our methyl ester, and then we have our cyclohexane, we have our 1-methyl, and then we have our carboxylate. Okay, on to ethyl-3-oxopentanoate. So, once again, we're dealing with an ester. So we can do that first. So it's an ethyl ester. So let's make our ethyl ester. There we go. So now we have our ethyl ester, and our base chain is it's a pentane because we see our pentan before our O8. So we have 1 carbon, 2 carbons, 3 carbons, 4, and 5. 1, 2, 3, 4, 5. Always counter carbons. And then we see oxo. So that's the prefix for a ketone, and it's at the 3 position. So 1, 2, 3. There. So that is what ethyl-3-oxopentanoate looks like. All right. Once again, we have methyl in front, and we see thioate, so that means we have a thioester. So let's first get our methyl thioester out. S, and click. Okay. So we see our methyl thioester right here. And we see p-bromobenzene thioate. So that means our base chain involves a benzene, and the P signifies the para position. So that means that our thioester and our the bromine from the bromobenzene are para to each other. So just like this, and then we add something to the para position. Perfect. So there is your methyl bromobenzene, bromobenzothioate. Okay, on to an anhydride. So we see that we have 2 names. That means we have 2 different substituents off the side. So we have formic and propanoic anhydride. So that means one of the anhydride chains, or like the alkyl chain for the anhydride, has to be a propane, and the other one is formal. So that means it just has a hydrogen. It's like an aldehyde. So there's our anhydride. And since formic is first, let's just put it on the left. So H. So this is the formic acid on the left. If you discount the other doubly bonded oxygen right here. So there's our formic acid. And then we have to go and make our propanoic acid on the other side. So 1, 2, 3 carbons is the base alkyl chain. And you can see this would make propanoic acid if it was if a hydrogen was attached to it. And together they make formic propanoic anhydride. Okay, and on to what looks like the last one. Cis-2-methyl cyclopentane carbonyl bromide. So what we see is we have a cyclopentane and we have a carbonyl bromide, which is what our carboxylic acid derivative is going to start with. So let's just start with that. So we have the carbonyl bromide right here. And then that has to be attached to a cyclopentane. So let's do that. Okay. And we also know that at the 2 position of the cyclopentane, so see how it's cis-2-methylcyclopentane carbonyl bromide? That means at the 2 position on the actual pentane is a methyl group. So we have the 1 position where the carbonyl bromide is attached. So this is the 2 position. And the only thing left we have to do is it does specify stereochemistry. So cis. That means the carbonyl bromide and the methyl group are on the same side. So I'm just going to delete this bond and draw it as a wedge, signifying that both the carbonyl bromide and the methyl group are in the same orientation. They're in the up orientation.